Professor, good morning.
Balaji, sir.
Sir, welcome Balaji sir. எப்படி இருக்கீங்க?
நல்லா இருக்கேன் மேடம், நல்லா இருக்கேன். நீங்க எப்படி இருக்கீங்க மேடம்?
நல்லா இருக்கேன் சார்.
Really happy to see you.
Yes sir. Yes. I thought of calling you, but வந்து வசந்த் வந்து கான்டாக்ட் பண்ணதுனால சரி அவரே பேசட்டும்னு இது பண்ணிட்டேன் நானு.
Yeah,
சரி
fine.
ஓகே. Anyhow, I am very happy sir. Once again, after a long time we are meeting.
Long time we are meeting. Yeah, true.
Yes sir. Yes sir.
So,
when does it start sir? At 10 o'clock or?
Yeah, it's 10.
It is about to start.
Waiting for Dr. Vasantraj.
Okay.
Yeah.
Within 2 minutes only, we can join.
Yeah, absolutely fine. No issues. So, madam, you are coming to campus, right? So, what about
Yes, sir.
online classes and all? How it's going? Like
Online classes, regularly online classes are going, sir, but
Fine.
the faculty members are attending duty regularly.
Oh, okay. So they have to come to campus and
Yes,
they have
yes.
to. Okay. Fine.
From last month itself, the faculty are regularly coming from last month.
Oh.
So we are having some other, already we are having lot of work in our documentation work. It is going
Yes,
on.
Understood.
So in this year we have to submit NBA also. So we are working on that. So autonomous, recently we got autonomous status. So that work is also going on. So a lot of work is going on for faculty members. Apart from that, they are handling online classes regularly.
Nice.
So the participants will join in a short time, sir. We can start the session, sir. Before I give you a introduction about yourself, sir. Resource person. Intro, sir. We can start, sir.
No, is anybody giving or shall I give on my own?
Yes, sir. No, nothing, sir. Our coordinators will give you the introduction about yourself, sir. Okay. So good morning, participants. It's a warm welcome to all of them. Today we're going to start a morning session with Dr. V. Balaji, the founder and director of Radiance Technology Services Private Limited. Today's topic is demystifying 5G NE radio, and followed by a demo on GNU radio. Before going to start the session, our coordinator, Mrs. M. Jivita, will give you an introduction about the chief speaker and a welcome address to resource person. Jivita, ma'am. Jivita, ma'am, you can start. Ma'am, your voice is not audible. Just louder.
Is Dr. Vasantaraj, what happened? Any, I think any technical issue from Jivita madam end?
So 1 second, sir. Ma'am, start, sir.
Yeah.
So good morning to all. It's a great pleasure for me to introduce our speaker, Dr. V. Balaji, founder and director of Radiance Research Service Private Limited, Coimbatore. Dr. V. Balaji completed his PhD from BITSP, ME in Digital Communication and Networking from Anna University, and BE in Electronics and Communication Engineering. He has 15 years of experience in academic and industry. His PhD work was in the area of cognitive radio networks. His research interest includes IoT connectivity solutions, 5G new radio, application of AI machine learning in Industry 4.0 solutions. He has published several research articles in various journals and conferences and published 2 patents. Prior to start his own company, he worked as a research mentor with CL Assenger Limited. He has engaged various research projects in academic institutions, provided radio access networks based design solution for IAC Bangalore incubated startup. Through his company, Radiance Technology Research Service Private Limited, he is focusing on offering research mentoring and technology solution support for academia, industry, startups and technology business incubators. The focus domains are 5G, IoT, cyber physical systems, and Industry 4.0 solutions. He has started up 360 programs sponsored by DFT in collaboration with Software Technology Entrepreneurship Park located at PSG Institute of Technology, Coimbatore. He has been a visiting research faculty in 3 autonomous engineering colleges located at Coimbatore. He is a member of IEEE Communication Society, Coimbatore District, Small Scale Industries Association, and the Indus Entrepreneurs Coimbatore chapter. Welcome you, sir.
Thank you, Jivita madam, for your brief introduction. And once again, good morning to all participants who have joined for this wonderful morning session. So let me quickly share my desktop. So is it visible, my desktop? So Dr. Vasantaraj?
Yes, sir. Yes, sir. Yes, sir. Visible, sir.
Fine. Thank you. Once again, good morning to all participants. So in this morning session, welcome you all for this wonderful session. So the next 2 hours, we are going to engage some kind of thoughtful technical interaction or discussion, I can say, about some advanced next generation wireless topic. So before getting into topic, I would like to extend my thanks to Professor Karthikeyani madam and the coordinator, Dr. Vasantaraj, right, for inviting me and giving me an opportunity to share my technical thoughts, right, for this wonderful session to all faculty members, right. So I hope the participants were from different backgrounds like doctorates and faculties who are pursuing their PhD and faculty members who are going to enroll their PhDs. I hope this session, it will really help you to take some key takeaways, right? So that I can guarantee you. So the topic for today's morning session is demystifying the 5G new radio and a small demo on GNU radio. So I have divided the 2-hour session into the first part. We are going to discuss about the 5G new radio concept, and in the second part, I'm going to give you some small demo on GNU radio. So that's the key focus of this the entire session. So the key takeaways, I can say that from at the end of this session, so you will get a good understanding about one of the emerging next generation wireless technology called 5G, and what are all the key technical specifications involved to build a 5G platform, and what are all the research topic or key areas where you can focus to take your wireless network research to the next level. I hope the session will be useful for faculties they completed their PhDs who want to engage on 5G related topics. For them, it will be useful, and also faculty members who are working on wireless communication related topics. So for them also it will be useful, and faculty who are exploring the potential topic to enroll their PhD work, right? For them also it will be a great benefit. I can say that beneficial, right? So that you can understand about the complete technical nuances of 5G, etc. Right? So the key outline is in the first part we are going to cover the 5G new radio. So as you can able to see why the 5G is called a new radio, right? So, and also I have mentioned another keyword which is coined by Qualcomm company. It's a unified connectivity fabric. I hope after the presentation you can able to connect these two keywords. Why 5G is called a new radio? So why the earlier generation like 3G and 4G, they haven't named it as new radio? So something new radio means some kind of technical and infrastructural changes are going to be carry forward in 5G network. That's why it is called a new radio, right? So we are going to see that part, right? So before getting into it, I'd like to start with, right, the kind of mobile communication, particularly the wireless communication revolution, how it happened. Generally, the thumb rule is like every 10 years, you will see some kind of technological advancement in mobile communication era, starting from first generation, second, third. I hope faculty members, I'm not going to give much introduction about the first generation, second, and third generation, right? So from fourth generation onwards, right, there are many mobile data traffic got exploded, and companies started working on big transformation of mobile communication after the introduction or after the realization of artificial intelligence and big data based technological algorithms, or I can say solutions, and it started growing, right? So other side, you can able to see the tremendous impact of those technologies in mobile computing and connectivity era also, right? So like that, the 4G is a platform, I can say, to realize the 5G network, right? So the 4G mainly we focused on mobile broadband and huge expansion of high-speed connectivity like gigabit LTE, LTE advanced and all, right? So from that timeline onward, right, 5G started coming into picture. So why the 5G platform is called a new radio means, so in 5G, we are going to see a unified platform which will connect various wireless-based connectivity solutions, starting from your mobile handset, connected cars, or connected smart factories. I can say that unmanned aerial vehicle like UAVs and drones, or connected industries, or connected virtual experience like augmented reality and virtual reality, right? And on-device intelligence and network intelligence. So all these modules are going to be connected to one single roof called 5G. That's why the 5G is called new radio or people named it as 5G NR. So one of the backbone to achieve all these is 5G is going to work majorly on a platform called wireless edge, which is the term introduced for 5G. Up to 4G, we focused on mobile broadband and high-speed connectivity. From 5G onwards, right, the computing going to play the major role on the mobile computing platform. That is one of the key change we can be able to see on 5G network, right? So in this background, so mainly as per various data by companies like Ericsson or Qualcomm, you can be able to see the kind of global mobile data traffic is increasing exponentially, not exponentially, it increased in a multi-fold way. So by 2024, the 25% of your mobile data traffic will be carried by 5G network. So many applications, like you can say that whatever application we are working on in a separate platform, everything going to be integrated in a 5G platform. That is one of the major technical, or you can say that transformation which we are going to see for the next 10 years. You can say that once the 5G will come into picture, right? So that is one of the, you can say that there are multi-X growth we can expect from a 5G platform, right? So as far as user perspective, right? So we can experience various connectivity solutions using the 5G, starting from high-speed mobility when you are on the go, right? Then excellent connectivity when you are in a congested environment, right? And also you can generate various data content on your single handset device, and we can connect everything like IoT and IoE using the cloud computing platform. So we can experience AR and VR with the 5G network, right? So the applications are endless. There are many applications. 5G technologies, it will open up many new application for the industries where they can work, they can focus more on, right? Already we are seeing the growth, how the data, right, how the big data started integrating, right, on our day-to-day life. Companies like Google, Amazon, right, so they are using data as the knowledge or wisdom to scale up their business, to introduce new use cases, right, with the help of advanced intelligent and computing algorithms, right, using the cloud platform network, right. So this, once the 5G will come into picture, it will unify all separate cloud-based application and use cases, right? So you no need to look for any other separate wireless connectivity solution. 5G will address everything from end to end. So 5G will act as a single end-to-end connectivity platform, right, for all your wireless-based solution. So that is a key goal started by a forum called 3G Partnership Project. So 3GPP is one of the forum who are authorized to release the technical specification for 5G. You can assume 3PP is similar to a IEEE standards, whatever IEEE standard we have, like 802.11 standard, right? So those standards, it will be continuously upgraded, regulated by IEEE. Similarly, as far as 5G is concerned, 3GPP is the authorized forum. So the team under this 3GPP involves various academicians, top industry players like from Qualcomm, Ericsson, Huawei, right? Various players. And also from our Indian side, ISC team, IIT Hyderabad team, right? And also people from CDOT, right? Troy, they are all engaged, right? So these people are releasing the document at various timeline to give the complete implementation shape to the 5G. Recently, you can able to see the release 15 is one of the recent launch technical document. So it is available in internet, so you can download, you can go through it. So there you can able to see the complete the technical details to realize the 5G platform, right? So as a long-term expansion, 3GPP is planning to give various industrial IoT related specification, how to deploy the private network using 5G, right? How to open up various unlicensed spectrum bands, right? So that we can connect, we can do the last mile connectivity also, right? So all those things are under pipeline. So 3GPP is a forum who are continuously working on expanding the new vertical, new deployment, new use cases, new spectrum opportunities, right? Related to all the 5G and beyond 5G, I can say. So ultimately, the obvious question will arise. So what is the role of our India, right? Where we are standing in terms of 5G implementation? If you see the earlier generation like 3G and 4G, so we were slightly lagging, right, to implement, right? But as far as 5G spectrum or the 5G deployment phase is concerned, so India is planning to work with developed nation to implement as early as possible 5G based platforms. So the Troy has opened up three range of frequencies already. One is sub 1 gigahertz, which is called 700 megahertz of band. Another one is sub 6 gigahertz, which will operate from 3.3 to 3.6 gigahertz. And also they opened up millimeter wave also, which will work from 24 gigahertz to roughly, I can say that 30 gigahertz. And also they have opened very higher order millimeter spectrum also. It will cover up to 40 gigahertz. So these millimeter wave for long-term perspective. And as far as immediate deployment, India planning to open up 700 megahertz, 3.3 gigahertz. So this is where India is standing in terms of 5G related implementation and deployment, right? So why, as I already mentioned, why 5G is called new radio, right? So there are two key fundamental technologies driving behind this 5G. One is called NFV, which is called Network Function Virtualization. And the second one is called Software Defined Networking. So these two technologies or these two concepts are essential 5G new radio expansion. So ultimately, these two technologies greatly helping 5G to achieve very enhanced mobile broadband, to integrate for a mission critical application, and also to realize the massive IoT, connecting billions of sensors on a single roof, right? So all these kind of things are possible with NFV and SDN. So we will see about NFV and SDN in the upcoming slides. So, LTE Advanced, right? Which started like roughly around 5 to 6 years back, I can say. LTE Advanced is a platform where 5G is going to build as an immediate deployment. So because the LTE Advanced already inherited various key features of the 5G new radio. I can say that starting from gigabit LTE connectivity, LTE spectrum sharing, and also cellular vehicle to infrastructure platform, drone communication, NB-IoT platform. So all these technological features are already integrated on LTE Advanced platform. So keeping the LTE Advanced platform in mind, so now network providers are starting to build 5G new radio platform, which will significantly improve the performance, scalability, and efficiency to realize enhanced mobile broadband, which is called EMBB, and ultra reliable low latency communication, which is called URLS. It will give latency rate of less than 1 millisecond. That is the full realization of a 5G once it comes into picture. We can experience low latency, and also we can deploy more private 5G new radio network, and we can share the spectrum. We can implement various IoT platform, and also we can integrate various vehicle to infrastructure based wireless connectivity like connected cars, connected railway networks, everything we can able to deploy using 5G platform. So the LTE advance is going to act as a backbone for 5G deployment, right? So the 5G, one of the key areas, we can say that a key feature we can experience from 5G is called the multi-connectivity, which is which will act as a integral part of the 5G design. So what is the multi-connectivity, right? So multi-connectivity means the radio or the system which will have the support to smooth transition between one spectrum of frequency to the another spectrum, right? So these can be possible by dividing the entire cell cluster into like a femtocell, micro cell, macro cell. So like that you can able to do, and you also you can aggregate various traffic, which is called carrier aggregation, right? So in this carrier aggregation, so you can limit the traffic which will work on below 6 gigahertz. You can assign the various application which will work on above 6 gigahertz. Similarly, you can assign some mission critical application or very high end application which need very high data rate application and all. We can offload it for millimeter wave latest frequency. So these kind of carrier aggregation is possible with 5G design network. And also a single device can able to connect all these kind of what you can say various feature which will work on various range of frequencies. That is one of the key advantage of 5G network. The multi-connectivity is integral part of the 5G design. So we multiplex various services which has the very wide band, right, and which has a narrow band application, right, for IoT related application. For IoT application, there are some sensors which may require very low data rate, right? Or there are many offline sensors also, right, which will not work continuously for 24/7. That kind of application you can use. And application like broadcasting and streaming application which need very large cyclic prefix, right? So like that we can do various subcarrier spacing, right, to integrate all these kind of services and support. That is possible with 5G new radio, right? So that's why the 5G, as I already mentioned, it is called Unified Connectivity Fabric. Why it is called Unified Connectivity Fabric is it has a more capability for air interface, supporting diverse spectrum. Like starting from, if you see the chart of 5G spectrum, so they have divided into 3 bands: low band, mid band, and high band. Low band, it will operate on below 1 gigahertz, whereas mid band, it will work from 1 gigahertz to 6 gigahertz, which is called sub 6 gigahertz band. And above sub 6 is called millimeter wave, which will operate from above 24 gigahertz. It may extend up to 168 gigahertz. Country like Koreans and China, right? So they have already done trials on 168 gigahertz also, right? So all these kind of trials are under phase. So to realize all these band applications, starting from low band to high band, obviously you need a multi connectivity platform. So the processor should support all these bands, starting from low band, mid band, and high bands, right? So you need a very advanced processor, has on-device intelligent computing and capabilities, right? So the reason why once the 5G will come into picture, the earlier devices, right, it will not support. It will become absolute. Obviously, the more new devices it will come into market, the user has to buy the new smart devices, or you can say the handset, to realize the complete 5G speed, or you can say the complete 5G related network support. And also the 5G, it will support the diverse deployment. So the key feature of 5G, I can say that diverse services, diversified spectrum, and also we can use on diverse deployment also possible with 5G. So all these ultimately it will decrease the end-to-end latency, right? It will give you the high throughput, and we can achieve very high network efficiency, and also we can increase the connection density in a particular geographic location, right? So all these things are possible with 5G platform, right? So under 5G, there are two deployment methods. I can say that, bro. So the first deployment mode is called non-standalone deployment mode, and also the second one is called the standalone deployment model, right? So as an initial phase, the network service providers are going to deploy 5G platform on a non-standalone mode. So in this standalone mode, 4G LTE advanced, it will act as a backbone, keeping that cloud as the core, right? So 5G, they will build, right? So it will support data plus control connectivity solution. So that it will, your device, it will support dual connectivity. It will frequently switching between 4G LTE link and the 5G NR link. Only these two links it will be available for the initial period of time, so that they can go for a very rapid deployment. They can launch very fast to the market. Once it comes into picture, right? Network service provider, they are planning to migrate to the standalone mode. So the standalone mode, it has more benefit like all this network function virtualization, software defined networking, then whatever fallbacks are there, and voice over LTE can be overcome by this voice over new radio. We can experience all this clear aggregation process. It will give tremendous support for all these millimeter wave type of application. So there are two deployment modes you can broadly remember in 5G. One is NSA and SA. So for the next 5 years, we can experience 5G on NSA deployment model. Maybe after 5 years, we can able to say SA model, right? So these are the two changes. So coming back to the question which I have asked earlier, right? Why the 5G is called a new radio? So this diagram, it will give you the clear picture about why the 5G is called a new radio, right? Here I mentioned the cellular infrastructure, right? The network structure of 4G from the traditional base station, and how it is working on 4G, and how the 5G is going to give tremendous change in the network management. You're able to see at the left hand side, right? The traditional base station, right? It has the antenna, right? Antennas are connected, and these antennas are connected to various RF amplifiers, right? Then from that we are having a coaxial cable connectivity. So this coaxial connectivity connected with the baseband unit and the radio head. Further from that going to the network. From the network, right, we are experiencing connectivity. So this is the traditional second generation network you can able to see. There are roughly 8 dual polarized antennas are connected, so we can able to achieve peak data rate of 4 Kbps. As far as when the third gen and the fourth generation started coming into picture, so network service providers done site modification. So they have made some kind of sophisticated arrangement on RF platform. So they have introduced major changes, fiber front haul network. The electric was connected with the coaxial cable. So coaxial cable replaced with fiber front haul. So because of these change, right? So we experience a very high data rate connectivity and enhanced broadband also, right? So these are possible with fiber front haul connectivity is connected with the backhaul network. So in all the baseband processing unit also mostly defined by software defined baseband processing unit as well as 4G is concerned. So still in these two methods, right? The antennas are passive antennas. So the passive antenna in the sense, so you have to design, fabricate, and you have to empower the antenna. What kind of task you want to perform at the baseband level. At the baseband level, so you have to define like the antenna pattern, right? Coverage area, right? Whatever antenna radiation pattern, everything you have to define separately. So antennas don't have that intelligence to take on its own decision, right? But as far as 5G is concerned, one of the major change you can able to see on the right hand side diagram, active antenna system. So what does it mean is antenna will act as a smart enough. The antennas are empowered with smart intelligence module so that it can relate and it can autonomously decide about its radiation pattern, coverage, right, everything. And also these active antennas are integrated with transceiver. So this is one of the key area where you can focus for your PhD work, or you can say that research work, right? So how to convert passive antenna to the active antennas? What are all the technical challenges are available? So that how you can design an antenna such a way that it will work as active antennas, right? That is one of the major change. The second change you can able to see in this diagram is virtual baseband unit completely connected with the cloud platform. That's one of the major change you can able to see. If you see the both the diagrams, right? In 5G, right, we are going to completely replace all the physical network infrastructure, starting from circuits, like physically connected RF amplifiers, right? So everything we are going to replace with a cloud-based platform. So it is completely all the traffic, right? Completely will be moved to the cloud-based network. So only the fiber front haul will be there. So that fiber front haul is directly connected to the cloud networks, cloud server. It's called network server. From network server to it will go to the user and servers, right? From the user and servers, the users can able to access the particular 5G network. That is one of the tremendous change we can able to see once the 5G will come into picture. That's why it is a new radio. Because in the earlier version, we are slightly modifying the existing infrastructure, replace or the earlier method of network infrastructure will become absolute. Right? Completely, it's a cloud-based network. Antennas are going to act as the smart antennas. Right? There are many arrays of antennas, like 128 to 512 active antenna arrays can be mapped at one base station. We can deploy that much high active antenna arrays. And also, we can achieve very high data rate of 10 Gbps. So this is one of the major change I can able to say as far as 5G is concerned. Hope you understood from what I mean to say, right? So keeping that change in mind, so we can scale various services, right? Once these change will come into picture at the network level, so we can able to achieve massive IoT connectivity, right? Let us say deep coverage, ultra low energy, ultra low complexity, right? And also we can connect n number of sensors, right? So everything is possible with 5G platform. So we can achieve enhanced mobile broadband, which will work on very extreme data rate. And also the That is the conventional IoT framework are currently working on. As far as wireless connectivity part is concerned, so either you will choose LoRa-based platform, right, or you will choose Zigbee or any other platforms, right? So, what is the drawback in LoRa-based platform? Anybody from the what is the drawback in LoRa? We're working on LoRa IoT projects, I think, because LoRa is one of the very well-known framework. Mostly we give to students to work on LoRa network. But what is the drawback of LoRa? Any participants? This is just you to alert about how you are following the talk. That's why I'm asking this question. So anybody interested, you can mute and you can share. What is the drawback of LoRa network? Sorry, LoRa-based connection. So the key drawback of LoRa is, I think somebody is doing unmute, I think, right? Actually, I think I'll proceed. Fine. So one of the key drawback of LoRa is, though it is a low power, long range connectivity. That is our main object, right? When we go for low power, obviously we can increase our connectivity range also. That is one of the thumb rule, as we know, right? As you increase the frequency, obviously you will get more